Hello and welcome, this is Dr. Snyder's assistant, and today is the day we have all been waiting for. Our first rendered images are supposed to be produced, so let's get at it. This is exactly what we are going for, and I'm wondering what will be required. So, first of all, we need a way to write an image. So PPM should do it, which is a very simple image format that kind of serves the CPP implementation quite well. And of course we need a renderer, which is nothing more than, well, an algorithm that is able to shoot rays in respective directions and put their results into the respective pixel location of the final rendered image. That sounds rather easy to do, and I guess we better get started setting up the basic structures here, the basic infrastructure. One tiny cut later, we are already there. The primary structure here is the renderer that contains all the information required to render a simple image. And its main render function just takes an image writer that is a trait which only gets to know when to begin writing an image of a given dimension, and then it can write each individual pixels. You know, we might change that at any time. It's just the very most direct version or thing I could think of here. So let's see how that works out. The first implementation of this image writer trait is the PPM writer, by the way, that is in its initial creation there. PPM is quite a simple and nice image format, well, just because it is that simple and usually supported by various image viewers. Besides that, the Ceepepporg version writes PPM as well, which is quite straightforward to do in code, as you see on the left side. Now to the actual crown jewel of the entire thing, the render method. All it needs basically is a scene, which is an intersectable thing. And right now it needs a pixel writer in order to write the result of the Raytrace operation, the actual colors, right? And all there is to be done basically is iterating the image across the pixels, like along X, along Y, and then you compute array according to the camera's eye location and shoot some rays and see if you hit something or not. So the first thing that I really want to do is just to have a black and white image that says, okay, there is a sphere or there is no sphere. Just keep it simple for now, right? And once again, doing any kind of math is terrifyingly difficult and ugly just because you have to use traits all the time. The simples operations are not that simple anymore, and it's quite incredible, and I really want to get rid of that as soon as possible. But for now, I will just deal with the legacy of Dr. Snidely, who will hopefully be back from holiday at some point, and yeah, keep going implementing that thing. A few minutes later, we are actually here in the Raytrace function. The Raytrace function is basically called for every ray that we shoot. It includes oversampling, and for now, all we want to do is check the scene if there is an intersection, and if there is some hit, we will just add white as a color, so that basically we signal, oh, there is something. As you can see, as we are in multisampling mode already, we will always add the colors instead of set them. It's a bit like a photon hitting our sensor, adding light to it. So in the end, the more photons we are being hit by, basically the longer our exposure, the more we have to scale the final image down to get an actual color that we can see. Similar to the Gopher implementation, I'd like to have a scene that basically represents everything that is important, that is a light, an eye vector, possibly. No, eye is a renderer thing currently, but I at least want to have the geometry in there and the light, just so that we can possibly extend on it later. The great thing about that is that we can then easily implement the default trait for the scene, which allows us to have a default scene that we can later use for actual ray tracing. Secondly, what we need is a main implementation, because our main program is supposed to be executable from the command line. That way we can first time actually generate an image and put it into some file for reviewing it later. I don't really want to do this in the tests just because it's kind of messy to output big amounts of data, and our PPM writer unfortunately is unable to write into a file right now. It can only write to std out. It's kind of hard coded to that. Something to be fixed certainly, but right now I just want to move fast and get to the point where I see some black and white image on my screen. And there we go. Yes, that's our first results of our hard work. It's amazing. The most beautiful gray spheres ever. I would have thought these spheres are white, but they ended up being gray. But you know what? I'm quite happy with that. But of course, that's just the first step. Next thing we have to do is to get some shading in there. That should be relatively straightforward to do from where we are right now, because it's just a few mathematical operations that we have to apply to get that going. So let's dig in. All right, once we have determined that there is a hit, the first thing, as we see on the left side, we have to do is to see if we are facing towards the light or away from it. Let's say that's how I interpret that operation, because I'm not quite sure if the hit position is equivalent to the normal, but certainly it's kind of used like that. But again, I'm just thinking out loud here. Maybe it's totally wrong, but that's kind of how it's supposed to work. So if that result is negative, we basically drop out right away. And if it is not negative, then we see if from that position we are able to trace to the light location. If that is the case, then obviously we are seeing the light, which means we are not in shadow. Otherwise, we are in shadow. And that's pretty much it, right? That's all already. So let's try to get that done here. Good. So here we go. And compiling, it works. Now executing the rendering. Come on, do it. There we go. Wow, that was relatively quick too. I mean, look at that. I think Ceepepporg version takes much longer. It takes like 0.4 seconds, or 0.5, or 0.6 seconds even. And yeah, so I don't know. I don't trust this. I don't think we are actually that fast. And as you have seen, there are no shadows visible, and our color seems to be overflowing. Yeah, I think that's an overflow there. And the moment we overflow, we start at 0 again. This is why we have the striping action going on. But it's better than just a gray sphere. So I think we are getting somewhere here. Also, the surface facing and not facing thing, that also kind of works, because the bottom of the sphere is dark, whereas the top is kind of in the stripy light. Well, I'm certainly happy with the result for today. I would call it a day even, because all the other stuff, like getting the rendering to work right, and I'd rather get a beer and do the next thing tomorrow. So, hope to see you there.
That and more in our next episode of Trace Quest 5.